Alrighty. Well, you guys have a good weekend? All right, I will begin with a word of prayer. Heavenly Father, we thank you for this day. Thank you for these students. Just ask you to bless this class today. Help us to, again, to glorify you in what we do, and just help us to understand the math as we go over it, Lord. In your name I pray. Amen. Any questions before I get into the new stuff? So we have a quiz Wednesday, right? It will take the whole class period, all right? You're allowed a page of notes front and back, a non-graphing calculator, right? It covers homeworks 1 through 4, basically. You're like, well, I haven't finished homework 4. I understand that. I will give you a good push in the right direction today. It's okay to not finish homework 4 before quiz 1. But I want quiz 1 to be basically a pretest, so it's just a fact of life. We have to cover some material on the quiz that we haven't quite got to in lecture. The reason for this is pretty simple. I want to grade the quiz and get it back to you, right? And I cannot afford in the semester like 2 weeks of review for every test period. So the only way I can really accomplish giving you a graded assignment with assessment back before the test is if I end up putting the quiz a little bit before the material. Now, the lion's share of the material on the quiz you've already seen in homeworks 1 through 3 and in lecture, all right? So really what's new for the quiz on Wednesday would be functions and lines, all right? And that'll be a relatively small part of the quiz on that. So any questions? Let's get right into it then. So to try to so basically, I would encourage you to pay a close special attention to examples in class today. You know, they're I will focus on things that are either helpful to solve your homework and/or the quiz. All right. So, but anyway, we want to understand what is a function. So, can you guys remind me what is a function? By the way, we're skipping over sections 2.1 and 2.2. 2.1 is on like Cartesian coordinates, like XY graphs, and section 2.2 is on circles. We will circle back to that later in the course. All right. So I'm diving straight into it, section 2.3, which is on how do you describe a function, right? So anybody remember? Well, here, let me suggest this. For me, the way I think of a function is a machine, right? Function f. So the way it works is I put in x, right? And what comes out? F of x, right? So this is the input. This is the output, right? And that's what a function is. Like, you know. That was, you also saw the lights blinking, right? Okay.
Yeah.
Okay, good. If it was just me, it would be more concerning. So, all right. It's important that for a function to be a function, there has to be a single output for each input, right? Like if you put one input and get 3 outputs, that's not a function, that's something else, all right? And so how do we describe this? Descriptions. So let me first say number 1 by a formula. Number 2 by a graph. And that could either be a list or a picture. Number 3 by a diagram. And number 4 by a table. All right. So these are 4 common methods. Now let me expand on this, all right? Let me expand on this. And as we do it, I'll introduce other terms that are important to us, okay? So, so formulas. Let's look at y, well not y, excuse me. So here's defined by a formula. So we could have f1 of x equal to say, I don't know, 1 over x. f2 of x equal to x squared plus 1. And let's do 1 over x plus 3. That'd be more interesting. All right, f3 of x equal to, oh, I don't know, how about 2 plus the square root of x? All right. So here's 3 examples of 3 different functions defined by a formula, right? Okay. Let me make a definition here. The domain of a function, right, is the set of all allowable inputs, right? In other words, it's all the allowed values which x can take. So for here, so for this, you know, it's the all x for which f of x is reasonable. Well, let's say is real valued. It's a real number. All right. So that's the domain of a function. And we have notation for that, right? Like what's the you know, we call that domain of f of x like that. All right. That's our notation. So you guys tell me, what's the domain of f1 of x? What's the domain of f2 of x? What's the domain of f3 of x? So like, which x can you put into the formula here? Here, I'll write it in this way. You say x such that x is not equal to what? What's the one thing we can't allow? 0, right? Now, if we want to put that into interval notation, what's it look like? This is minus infinity to 0, unioned 0 to infinity. So there's the domain in interval notation. What's the domain in interval notation of f2? Which x can you not square and add 1 to? You can do it to a negative number. You can do it to 0. You can do it to a positive number. Hey, that's everything, right? So this is a quadratic polynomial. The domain for any quadratic is just all of the reals. So it's very silly, but the domain here is just everything. Okay. How about the 3? What do we need for the formula f3 of x to be a real number? What kind of condition do you need on x? Last class told me I needed to make x positive. Do you guys agree? And I said, well, I almost agree with that. I mean, that's good, but can you do better? Like, should you include 0? Should you exclude it? See, I think positive's good, but non-negative's better. See, because the square root of 0 is allowed, right? So we can include 0. The square root of 0 is just 0. So there you go. That's the domain. All right. Now, so the principle here is, given the formula, you define the domain as in the most greedy way possible. You choose all possible x, which makes the formula real valued. That's our convention in here, okay? Now, what else can you talk about for a function? How about what's the range of a function? What's the range of f of x equal to? All outputs for the function, right? Was it something I said? No? Okay. All outputs for the function. So, in other words, you know, if y equals f of x, all y values which are attained, all right? So if you have a formula, right, And you look at y equals f of x, what's this called? This is called the graph of the function, right? So it's interesting to look at the graph of f1, f2, and f3. Can we draw those down here? I think we can, right? So listen, we're going to learn how to systematically graph things after test 1, so I'm just going to give you the graphs right now. I don't expect you to create graphs on test 1 or quiz 1, but I might expect you to read from a graph, which is given. Okay, that's the difference. So I'll do the part that you don't have to do, namely make the graph here. So this one's got a horizontal asymptote I'm trying to do a horizontal asymptote of 3. All right. And y equals f1 of x, it looks like this. All right, it's got what's called a vertical asymptote here at 0. So we're looking at y equals, 1 over x plus 3 in this picture. All right. The graph of x squared plus 1, it's just got this turning around point here like that, and it goes up and up like that. That's y equals x squared plus 1. The square root of 2 plus the square root of x, it starts up here at 2, and then it's like half of a parabola like that. All right. So if you have the graphs of the function given to you, right, you can figure out the range by looking at the graph, right? So you guys tell me, what's the range? So using the graphs, over there, we see the range of f1 of x equals to what? The range of f2 of x equals to what? The range of f3 of x, what is that? So help me fill in the blanks here. So again, the range are possible y values of the graph, possible outputs, right? So what do we got?
Negative infinity to 3, and 3 to infinity.
Yeah, I heard negative infinity to 3, and then 3 to infinity. Now we need to put those together, right, with a union. So that's that one. Totally agree. How about range of f2? What are the outputs allowed here? We're this point right here, right? This point is 0, 1, right? More on this in just a second, but f2 of 0 is equal to 0 squared plus 1, right? Which is equal to 1. And that value is at what we call the vertex of the parabola, right? More on that after test 1. All right, that's test 2 material. But anyway, that's the smallest it can ever be, right? And it just goes up from there. So what's the range? The range is 1 to infinity, right? And how about this guy? Range is starting here, this point right here is actually 0, 2, yeah? And so it goes from 2 to infinity. All right. So just to recap here, given a formula, right? We will later learn how to make graphs of the formula, right? If you have the graph, you can see the range from looking at the possible y values in the thing, right? The domain, on the other hand, you don't have to make the graph, right? To figure out the domain, we just need to figure out which x values are allowed. And we didn't have to draw these pictures to figure that out. All we had to do was think about the formulas, which x are allowed, right? So the domain is the set of allowed inputs, right? So this is the formula viewpoint, right? Now let's talk about by graph, all right? The graphical viewpoint. Although I guess I should pause here and just make a comment. Evaluation, right? Let me stop and talk about evaluation here for a second. So Evaluation is a fancy word for sticking a number or an expression into the formula, right? So you plug something. This is just plugging number or expression into the formula. So like, just for reference, let's call this one example 1, example 2, and example 3 for my F1, F2, F3. So I'm going to call this, what I'm about to do here, example 4. You served me well, but your life, it's over. Sad. So sad. I'll eventually learn how to throw. Let's see here. I did play Little League. I really have no excuse. I mean, I was catcher. I used to be able to throw to second base, no problem. These are just not weighted right. Anyway, example 4. So suppose you had f of x equal to, I don't know, x cubed plus 3x minus 2. All right? There's a function. We gave you the formula. Now you can ask questions like evaluate f of 1 and f of, I don't know, Pac-Man plus Ghost. All right. In order for me to put that on the test, I need to find a font package which will make Pac-Man and Ghost to my liking. So it's probably not on the test. But if I could find the right, there is like a Halloween font which has like bats and stuff. But I'm not sure I can get it working at the moment. Anyway, f of 1, all that means is you take x and you replace it by 1, right? So we got 1 cubed plus 3 times 1 minus 2, also known as what? 1 plus 3 minus 2, 4 minus 2 is 2, right? So evaluate the function. This just means we plug the value into the function, right? Not bad. And how about f of Pac-Man plus Ghost? What's that mean? It means you take everywhere there's an x and you replace it with Pac-Man plus Ghost. So in order for this example to be meaningful, I'm insisting that Pac-Man and Ghost share the same units, right? Otherwise, physicists or chemists or whoever will fuss at me because you can't add things with dissimilar units, right? Like you can't add a force to a velocity, for example. All right, I'm just messing around. My point is, there are problems in your homework where it's like evaluate f of a plus 3. What that means is you take x and you replace it with a plus 3 and you work it out. Right. Now those ones have you there was one that says like evaluate and simplify. Then you'd actually have to multiply it out and subtract things. That's beside the point here. All right, so I'm going to leave it at that. Are we good? All right, so let's move on to by graph. So there's really two cases here, which is one case is you could be given a picture, all right? And if you were given a picture, it could look something like, I don't know. How about like this? We could go, say, from here, which I'm going to say is minus 1. Well, let's say that's minus 2, rather. Minus 1, all right? And then up here to this point. And that point, I'm going to say, is at 3... I don't know, 3, I'm going to say that's at 3, 4, just for the sake of discussion, all right? Then I'm going to jump over here. Well, I should write under here. So this point right here will be 3, 1, all right? And then I'm going to go down here like this to this solid dot, which is going to be at actually, I'm going to go a little bit short of that, excuse me. a little bit up, a little bit up. I'm going to put that one at, let's say 6, comma, minus 0.5. All right. And then from there, I'm just going to go constant all the way over here to, let's say, 9, comma, minus 0.5. All right. You guys have a much more, like if you go back and watch the previous section, the example I gave them was far less interesting. Your example is much better. You should be happy. I've added great value to your lecture with this example here. So, so this is example 5. Okay, so like this is what's given, okay? This is given. All right, so if you're given that, then we can ask a whole bunch of questions, right? We can ask what's the domain, we can ask what's the range, and then we can ask more specific questions. Like I'll start out with the specific questions here. So, you know, f of minus 2 equals what? F of 3 equals what? F of 6 equals what? F of 8 equals what? F of 9 equals what? So what, and what? Now, the first one is a trap. It's a trap, all right? Because you see this circle right here? That means that we're not giving a value for the function at minus 2. So f of minus 2 does not exist if this is the graph. So we say dne, all right, does not exist. Now f of 3, go over here, right?
4.
F of 3 is 4, thank you. How about f of 6? Negative 0.5. We're good. And how about f of 8? Again, negative 0.5. Of course, now here we're begging that my picture really is, you know, horizontal there, right? So, you know, that's under that assumption. And what's f of 9? Again, yeah, negative 0.5. And so the difference between the minus 2, right, that we started with, and the 9 we finished with is that 2, the dot was open, which means it's not included in the domain. Whereas, and over here, the dot is filled in, which means that the point is in the domain, right? We can do a little bit more here. So for example, can you guys tell me on what interval is f increasing? Increasing on fill in the blank. F is decreasing on fill in the blank. F is constant on fill in the blank. We use the, so when you ask questions like this, we're always referring to the x values. So negative 2 to 3. Decreasing, 3 to 6, very good. Constant 6 to 9, right? Now it doesn't matter whether you include or exclude the endpoints here. It's not meaningful. You can exclude them, you can include them, it doesn't matter, okay? Just to be safe, to make sure we're being most logical, let's just exclude them, just to be, that way I won't get into trouble. See, I would say I'm a little bit getting into trouble if I include the minus 2 because it's not in the domain of the function. That's probably bad form to include the minus 2, all right? All right, so increasing, decreasing, right? So when you're thinking about decreasing and increasing, you have to think about reading the graph left to right, right? It's increasing if the graph is going up. It's decreasing if the graph is going down. That's pretty much it, right? Constant, self-explanatory. Okay, so now let's main event here. What's the domain? What's the domain of f of x here? And what's the range? So the domain is the allowed inputs, right? The allowed x values. So we're going from -2 not included all the way over here to 3, right? 3 is included up there, so it gets included. Then we keep going all the way over here to 9. So it looks to me like the domain is -2 not included, all the way over here to 9 included. So that's the domain. Now if there was a jump, right? If you skipped some values in x, you'd have to take a union of two things. All right, that could happen. How about the range? What's the range here? -1 to 4. Now do you include or exclude -1? Exclude, very good. And 4, we include, right? So the way to think of this, the way I think of this, is to figure out range. I imagine taking horizontal lines, all right? I imagine taking horizontal lines and passing them through my graph. And if the horizontal line hits something in the graph, then that is a y value that's in the graph, right? So it doesn't quite intersect it at -1, but everything above that, there's at least one point where it's hitting the horizontal line, right? All the way up until I get to 4. Now once I get past 4, there's nothing in the graph that's hitting this horizontal line, right? So you can just think about slicing the graph horizontal lines, looking for the y values which are hit, right? And that's how I think about range. Range is the set of y values which are attained. Now for the x values, you could use a vertical line, right? Kind of just like go across and look for, as long as there's one point the vertical line is hitting, right? That's a point which is in the domain. So this is for domain. Look at vertical lines, right? Questions? Now, if you've looked through your homework, you realize that there are other problems in the homework which are weird, right? They're not like this, are they? So I should mention definition. The graph of a function is the set of ordered pairs, x comma y, such that x is an element of the domain of f, right? And y is equal to f of x. So the graph of a function is a set of ordered pairs. Your book takes the viewpoint, actually, that the graph is the function. So sometimes they'll refer to a collection of ordered pairs as if it is the function, all right? So like example 6 here, they could tell you graph of f equal to 1, 2, 2, 4, 3, 6, right? This is a way they could describe a function. This is a kind of boring function. What this means is that f of 1 is equal to what? F of 2 is equal to what? F of 3 is equal to what? Can you tell me? 2, 4, and 6. Correct. So, see, that's just because the graph is pairs of the form x comma f of x, right? Like another way you could write this up here would just have been x comma f of x, right? Such that x is in the domain. So if we give a list of pairs, the first thing in the pair is the x value. The second thing in the pair is the y value, right? That's the other way of talking about it. Example 6, what's the domain? What's the range? What's that? From 1 to 3. Not, I wouldn't, well, I mean, what do you mean? 1, 2, 3, like that. 1, oh, 1, 2. So you're saying, I said this, I didn't, you're like, you're putting words in my mouth. I didn't say this. But how do we read that closed interval? I read it, the closed interval from 1 to 3, which is different than the set containing 1, 2, and 3. but we verbalize them almost the same. That's why I thought you were not wrong, though. Thank you, sir. What's your name? Stefan. Stefan is correct. Yes, 1, 2, and 3. This is a set just containing 3 elements, right? In contrast, this over here, how many points are in the closed interval from 1 to 3? All numbers from 1 to 3. How many numbers are between 1 and 3? A lot. Yeah, that's a good answer. Infinity, right? There's too many. So this is not the case here. Okay, so that's the domain. What's the range? 2, 4, 6. Yeah. If you wanted to graph, like literally graph in the sense of XY coordinate plane, what would the picture look like here?
It would be like a diagonal.
I'll put it up here so everybody can see it. But if this is 1, 2, 3, and I'll try to make it. Here's 3, here's 6, right? And I'll make my graph in red. It's a very silly graph. It has the point 1, 2 on it. It has the point 2, 4 on it. And it has the point 3, 6 on it. And there you go. That's y equals f of x. Right there. So we don't typically, I mean, like your book doesn't, I don't think the book even has a picture like this in any of your homeworks. So when we're dealing with these silly examples where you just have a finite number of things in the domain, they just write them as lists, right? Or you could also write it as a table, or even a picture. Let me. So like I said, the other description are by diagram or table. So diagram and table, this really, diagram and table really only works for these kind of silly examples where you have a finite number of points, you know. So let's see here. So example, 3 diagram. So I'm going to continue example 6 continued. So I had 1, I had 2, I had 3. I went to, 4, 6, wait a minute, my bad, 2, 4, 6, right? So the diagram here is exceedingly silly. It's just 1 goes to 2, 2 goes to 4, 3 goes to 6, like that. So this diagram means, so if this defines f, that means f of 1 is equal to 2, f of 2 is equal to 4, f of 3 is equal to 6. And so, like, if you have a diagram, the domain is the numbers on the left, the range is the numbers on the right. That's it. That's a diagram. How about table? Tabular. Well, that one we could do like this. We could say x, we could say f of x over here. You make 2 columns. You got your 1, you got your 2, you got your 3. The outputs were 2, 4, 6. So this is another way to define example 6 function with a table, right? That table means f of 1 is 2, f of 2 is 4, f of 3 is 6. Again, very silly. Now, dang it. It's not a good day for pen throwing, I'll tell you what. Any questions? All right. So I've told you the 4. Of course, we can also use a table of values to gain insight into a function with, like, this is a complete table in the sense for example 6, right? In the sense that it has a row for each possible value. I could also make a table of values for a function which has a larger domain. Like I can't list all of them, right? Like, example 7. I could have something like, oh, I don't know, f of x equals to x squared plus x plus 1, right? The domain of this would be what? All reals, right? Unless we say otherwise. And I could still make a table of values for that, right? It wouldn't define the function, but it would give me insight into it, yeah? So like, how about this x, f of x, right? And, you can put in whatever we want. I mean, we can do anything we want. -2, -1, 0, 1, 2, right? And you just plug them in and put them over here, right? So like we get what, 4 minus 2 what's that? 3, yeah. So you got a 3 for that. I think I made my table too small. Sorry, guys. This, if you don't mind, I'm just going to work it out and put the number. If I plug in -1, I get 1 minus 1 plus 1. I think that's 1, right? If I plug in 0, I get 1. If I plug in 1, I get 3, right? If I plug in 2, I get 4 plus 2, which is, I get 7, right? Does anybody want me to explain where those numbers came from? Yep. Sure. Which one? The last one?
Yeah, last one.
Oh, okay, so f of 2 equals 2 squared plus 2 plus 1, which is 4 plus 2 plus 1, which is 7. And so all of these numbers are arrived at in the same way, just by plugging the x into the formula. Yeah.
Thank you.
No problem. And so if we make a table of values, of course, we can use these to create a graph, right? I'm not going to ask you to do this on test 1. Like I will give you graphs and ask you to interpret them. I don't really intend for you to make a graph, with the exception of lines. I do expect you to be able to draw a line with a given slope, intercept, points, that kind of thing. All right, we will cover that. Okay, so one other topic, just in terms of basic function stuff that we need to talk about, is when is it not a function? Is a graph not the graph of a function, right? So let me give you a picture. So we could have something like this, right? We could have something like this, all right? And we could have something like this. These are all graphs in the xy plane. A graph in the xy plane is really just any old subset that you can imagine. So, what constitutes a graph in the xy plane? It's just a subset that you're picturing, okay? Could be all kinds of things, right? So the reason that the first one is not a graph is because it fails what's called the vertical line test, right? What's the vertical line test? Yeah, if you can find a vertical line which hits the graph in 2 points, what does that mean? That means it's not a function. Why is that? Because if we look at this point, maybe it's, this is the circle, so I could give you an equation for it. X squared plus y squared equals to 1, for instance. And if we're at -1/2 here, then what are the y values? We'd have a -1/2 squared, right? Plus y squared equals to 1, which would give me y squared is like 3/4. So y would be plus or minus the square root of 3 over 2. So then you got to choose, right? Is f of minus a half, is it plus or is it minus the square root of 3 over 2? See, you can't have both. A function's single valued. So this is not a function, right? It's not single valued. So what I'm telling you is if we fail the vertical line test, which means that we take a vertical line and there's some point, some x value in the graph where it intersects the graph at more than one point, that corresponds to the reality that the function needs to output more than one output for that given input, which is not allowed. A function has to be single valued, right? So, and it could get worse, right? Like this, maybe I wasn't done drawing this yet, right? It could do like this. That's a graph, right? And this one's really bad, It's hitting, this vertical line hits not one, not twice, not 3 times, 4 times, 5 times. That, if you take that x, in order to get all those y values, you'd have to output 5 things, right? That is not a function. And that graph fails the vertical line test. In contrast, over here, right, we're good. Every vertical line that you can draw, there's not exist a vertical line that hits the graph in more than one point. It's okay for the vertical line to not hit the graph in any point, right? Like if the function stops right here, right? Maybe it keeps going that way, but if it stops right here, it's possible to have a vertical line like this, right? Which doesn't hit the graph in any point. That's fine. So to be careful, we should say the vertical line test says that a given graph is not a function if there exists a vertical line which intersects the graph at more than one point. Right? That's it. There's also a horizontal line test, right? Which is to look at horizontal lines passing through the function, but we'll talk about that later. We need to think about that when we're thinking about inverse functions and what's called the one-to-one property, but that's for later, all right? Okay, so that's, how does this appear in the finite list world? If you're writing your, if you write your function as a list, what would that look like? You don't really want to. Do you really want to make this kind of picture for every one of these problems? I don't think you do. You don't want to make the dot picture for every one of these problems, right? So how about this? You guys tell me. Well, let me just give you a couple of more examples of not a function. So non-functions, okay? Not a function. Continued, all right? So I guess this was example 8, yeah. All right. So call this example 9 here. So maybe we're going 1, 2, 3, 4, and then our outputs are 10, 20, 30, and 40. All right? And our diagram looks like this. So what would this mean, this picture? This would mean f of 1 is equal to 10, and f of 1 is equal to what? 30. But this is not allowed. So therefore, it's not a function. 1 input, 2 outputs, game over. Everything else is okay, right? F of 2 would be 20. From this picture, f of 4 would be 30. F of, and so forth. But here's another one. 1, 2, 3, 4, 10, 100, 1,000, 10,000. All right? Suppose we had this. Here's the picture. 1 goes to 10, 2 goes to 10, 3 goes to 10, 4 goes to 10. My question to you is this a function? I see some nodding. Right, there's no problem here. This just means that f of 1 is equal to f of 2 is equal to f of 3. They're all equal to 10, right? And if the picture looks like this, this is a little bit tricky. I said earlier that the numbers on the left are the domain and the numbers on the right are the range. That's not true for this example, right? What's the domain? For this example, the domain is 1, 2, 3, and 4. What's the range? It's just 10, right? So it's kind of silly. So that comment I made earlier, it's the numbers on the right that are the range. I'm assuming that there's an arrow going to each number, right? So maybe you wouldn't even draw these numbers, then that would be still been true. All right. So, example 11. What if you had graph of f 1 comma 2, 1 comma 3, 2 comma 7, like that, right? Is this the graph of a function? Or in other words, does this define a function?
Yes.
The answer is nope. See, here's the trouble. Right here, this would say f of 1 was 2, and it would also say f of 1 is 3. This we cannot allow, right? Well, we have to have, so for it to be the graph of a function, if you have a set of pairs, it's got to be the case that the first number in the pair is never repeated for any two pairs. Like yeah, I mean, oh yeah, sure. Like if we had, I think you're asking, what if we had, instead of like I did, like 2, 1, 3, 1, let's say 7, 2, for example.
Yeah.
That would be a function because, see these numbers, 2, 3, 7, they're distinct.
Okay.
As long as the first number in the pair are distinct, then those are the x, those are the domain. So if we had two pairs that had different x's, excuse me, if we had two pairs that had the same x but a different y, that would mean that the function is outputting two different things.
Let's say like an example 11, like one of the ones is excluded, could you still say it's a function or
Oh, you mean if I just threw out one of the pairs? If I could just cut one of them out?
3 in one of the sets it's included and the other one it's excluded. And
Wait, what? Which one? What?
in the graph over here, like 3, 4, that one 3 is included and the other 3 is excluded.
Oh yeah. Yeah, if I wanted to ruin this and make this not the graph of a function, all it takes is if I just fill in that dot, game over, then we failed the vertical line test right there because we'd hit those 2 points through that one vertical line if I filled in that dot. So the thing that remains to tell you guys about is lines. I need to teach you about lines. That's going to happen Friday. I was asked earlier, this last section asked me, are we going to review this week? Well, not exactly. We're going to cover sections 2.3, 2.4, 2.5. Next Monday, I do have completely reserved for a review, if I remember my schedule right. So yeah, like next Monday, 9/19 is questions for test 1 in here, right? So there we'll talk about the solution to the quiz. We'll talk about, whatever questions you have left about the material. Friday, I'm mostly going to talk about lines. If you want to get a jump start for the quiz Wednesday on lines, just work the last 2 problems in the homework are in parallel and perpendicular. That's probably the part you forgot about. So if you read this section about that and do those problems, you'll be like aces. If you don't, you'll still be fine. This will be bonus credit on the quiz. So even if you don't understand everything about lines and functions, you still can make 100. So I hope that makes sense.